Hi, Mr. Bennett here. The last part of the momentum in 2D is these type of diagrams where we have two objects colliding or interacting with each other. So if you can think of the example might be on a 8-ball table when you're hitting the white ball into another ball and those balls are rebounding to other balls, or off the cushion, you know, you have an interaction. All right, so we have a change in momentum and so on. So that's the case here. We will be doing this as a prac, looking at the change in momentum, seeing we have conservation of momentum to prove that. So if we look at this scenario, this diagram here, it shows you what's actually happening to the balls initially, the two pucks, and then afterwards. It shows the interaction of those particular pucks. Now, we would be using flash photography for this. So if we're using flash photography, then each of these particular images occurs at the same time period. So we know that momentum is change in velocity over the mass, or change mass times by velocity. So we do know the masses here, and we do know the velocities here in respect to each other. So let's say, you know, we know that this thing here has travelled a certain distance over a certain time period, then we can compare the distance that travels with this one over here, if you understand what I'm trying to say. So let's just go through an example of what might happen here, and I'll show you how you do the interactions. All right. So technically, and mine's not going to be as accurate as yours because you'll be working from a diagram, which will make life a little bit easier for you. So if we were looking at this, we've got the same time period. So what I'd have to do is I'd have to measure this distance here. All right. So let's say that distance there is 6 centimeters. All right. And I also measure the distance here, right, and that's something like 10 centimeters. All right. So we're comparing those two things there. Now, this has a mass of 2 kilograms and it has a mass of 3 kilograms. So what I could do is I could say the unit over here of number 1 is going to be 6 times by 3, which is 18 units. I'm not going to use second newtons because that's not what we've got. Over here, we're going to say the mass is 2 kilograms by 10 centimeters. So therefore, momentum number 2 is going to be 20 units. Alright, so that's a representation of the two momentums of that. So with momentum, the direction is also very, very important. Alright, so this one, we've got one vector going that way upwards, and we've got another vector going that way. So what we should do is get our ruler. Now I'll use my vectors because I think I've got some vectors here. So what I would do is I'll get my vector and I'll draw a line, and I would suggest that you start over here and you draw your vector going like that. Alright, so if I just change that so you can see it a bit easier, just change the weighting of that to be a bit darker. So you can see it easily. Alright, so that's my first momentum vector. Alright, and then what I do is I add my other vector. So what you do is you simply get a ruler, and you would have your ruler going along the line of that, and I'll show you this in class. But what you'll do is you'll insert your other vector, and your other vector will go from that point there and will go up at the same particular slope as that other line there. And you could even change the colour, that's if you wanted to, just to see, make sure that you understand that they are, it's a different vector in that particular direction. And so the thing here, what you've got to try and do is fit this on your page. Alright, so for this particular one over here, because it's actually 18 units long, just so it might fit on my page, I actually might make that equal to maybe 9 centimeters. So I'm going to do it to scale, even though it's not, you know, it's a sort of representation. This one here is 20 units, which means I would draw that one there 10 centimeters long. Now my final momentum vector, this is my initial momentum, would have to be a vector which goes from the start of where I started to where I finish. So my momentum vector would be a vector going in this direction here. Right? So that is my initial momentum, and you know, I could certainly change the weighting of that again, make that a red vector just so it stands out. And remember, you're probably doing this by hand. Alright, so that is my initial thing, so then I can measure it. Let's measure the length of this particular vector over here, and I measure the length of it, and it works out to be, what would it be? Probably 15 centimetres. Okay, so let's say it's 15 centimetres long. Then I know my initial momentum is equal to 30 units. Okay, so that's my initial bit, which is pretty easy to do. And then what I do over here is I do the same thing. Alright, so I measure the distance here for 2 lengths over there, and that works out to be 7 centimetres. I do the same thing over here. Alright, that works out to be 10 centimetres. Right, so that there, it works out to be 30 units. That's P1 final, so that will be 30 units. And this one over here is 7 times that, so P2 final is equal to 14 units. Right, so then I do the same thing again. Alright, so what I might do is I might do my vector, okay, over here. So if I insert my vector, and I have to do the same thing, so starting maybe from that point there, and drawing my vector. Keeping in mind, we're going to try and keep this on the same page. So you might actually work with this one going back this way. So if I was going to do that, just so you can fit it on the page, I would have my vector going there for the first one, and then I have my second one going over there, and then what I'd do is I would have my vector, my final vector, going from this point here, and it's not going to, just need to make sure this fits on the page. Right, so I move that up to where it goes. I measure the length of it, so this would be over here. This one over here would be my final momentum, P final, and let's say that worked out to be 15 centimetres, then I would know that would be 30 units. If it wasn't 15 centimetres, then if it was 14.8, that's pretty close. I could almost round that off to say there are some measurement errors there. If it was say 14, you're not going to be that far off. All right, so therefore you can say there's no conservation of momentum there. Therefore, it's not an elastic collision for this particular case. Hopefully that makes sense. We'll do some of these in class, and I'll work with you on that. But essentially, it's about drawing the vector diagrams and making sure you're using the time scale here to get your lengths. So that time scale allows you to work out what your velocity is as a representation. And that's sort of, you know, a very typical sort of question that you might see in an exam. All right, so I'll leave it there for today. But like I said, we'll be working on these in class.